In this video, we will be looking at section 3.2, which covers quadratic functions. We most commonly look at quadratic functions in standard form, which would be f of x equals ax squared plus bx plus c. This form is really nice because we can use the quadratic formula to solve for x. One that may be new to you is the transformation form, which is also known as vertex form of a quadratic function. If you remember back to when we were doing transformations, this should look familiar because we have our vertical stretch or compression out front and then our horizontal and vertical shifts. When we're working with this vertex form or transformation form, the vertex is going to be located at h comma k. And this vertex, remember, is the turning point of the quadratic equation. To find the vertex when we are in standard form, the x value is at negative b over 2a, and the y value is found by plugging that x value back into the function, so that the y value will be at f of negative b over 2a. So we're going to start by finding the vertex of a quadratic function. So first up, we have f of x equals x squared plus 12x plus 32. We know that the x value is at negative b over 2a. So in this case, that will be negative, my b value is the coefficient on x, so that's a 12, over 2 times my a value, since I don't see a coefficient here, it's going to be 1. And negative 12 divided by 2 is equal to negative 6. But now I need the y value of my vertex. So I need to find f of negative 6, which will be negative 6 squared plus 12 times negative 6 plus 32. Negative 6 squared is 36. 12 times negative 6 is a negative 72. And we have a plus 32, and that gives me a negative 4. So the x value of my vertex is negative 6. The y value is negative 4. My vertex is at negative 6, negative 4. Looking at my function g of x, we have negative 2x squared plus 8x minus 3. To find the x value of the vertex, we use negative b over 2a. Which will be negative 8 over 2 times, my a value this time is negative 2. And negative 8 divided by negative 4 is a positive 2. To find the y value of my vertex, I plug that 2 back into the function, and g of 2 is equal to negative 2 times 2 squared plus 8 times 2 minus 3. That would be negative 2 times 4 plus 8 times 2 minus 3. That would be negative 8 plus 16 minus 3, which would be 5. So my x value is 2, my y value is 5. The vertex is located at 2, 5. Now we're going to look at the graph of a quadratic or a parabola and see if we can find an equation for it. This is pretty much section 1.5 again. We're just going to focus on the quadratic. Now remember that transformation or vertex form we had before? It said f of x is equal to a times x minus h squared plus k. In this form, our vertex is located at h comma k. So we need to figure out where our vertex is. The vertex is the turning point, which is right here. And that's at x equals negative 2, y equals negative 3. So negative 2, negative 3 is our vertex. I'm going to plug that in to my vertex form. So we'll have f of x is equal to a times x minus negative 2. Well, minus a negative 2 turns into plus 2. That squared plus k is really a minus 3. From here, I need a point on my graph other than the vertex. Any point on this graph works as long as it's not the vertex. I kind of like this guy because it has a 0 in it. I know that the point 1, 0 is on my graph, so I should be able to plug that into my function and get a true statement. So that would give me 0 equals a times 1 plus 2 squared minus 3. So 0 is equal to a times 3 squared minus 3. So 0 equals a times 9 minus 3. But a times 9 is just 9a. So 0 equals 9a minus 3. I add the 3 over. 3 is equal to 9a. Divide by 9. A is equal to 3/9, which simplifies to 1/3. Now that I know what my a value is, I need to plug it in. My function is f of x equals 1/3 times x plus 2 squared minus 3. That is an equation for this graph. So that's kind of interesting. Let's see if we can switch between forms. So we want to put the equation y equals x squared minus 8x plus 15 into the form y equals x minus h squared plus k. You may be wondering where the a went here. But what's really neat about quadratics and these two forms, our standard form and our vertex form, is that the a value in both of them is the same. So in this case, our a value is 1. That means if I were to switch forms, my a value would be 1 here as well. So if it's 1, I don't have to write it. So that means I just need to find my vertex. My vertex is found by first finding the x value by using x equals negative b over 2a. So that will be a negative 8 over 2 times 1, and 8 over 2 is 4. Now that I have the x value, I need to find the y value. Y is equal to 4 squared minus 8 times 4 plus 15. That's 16 minus 32 plus 15, which is negative 1. So my x value is 4, my y value is negative 1. I'm going to plug that in. Y is equal to x minus, remember that my vertex is written as h comma k, so I need to subtract 4. That's squared, plus my k value, so plus a negative 1 makes it a minus 1. We're going to take a look at a couple quadratic applications. So Jamie designed a new style of sports bike and wants to sell them. Jamie found a function to model the profit received on the bikes. P of C equals negative 200C squared plus 92,000C minus 8,400,000. That's a big number. Where P represents the profit in dollars received from selling the bikes for C dollars. We want to determine the price Jamie should sell their bikes for to earn maximum profit and find the maximum profit. When I see maximum, I think the highest. Well, if you think about what the graph of this function would look like, it's a quadratic, so it's a parabola. But since we have a negative out front, we know it is a downward opening parabola. So if we're looking for the maximum, we're just looking for the vertex. So if we want the vertex, then our x value, which we're using c instead of x, will be at negative b over 2a, which would be a negative 92,000 over 2 times negative 200, which is negative 92,000 over a negative 400, which is 230. That means that our C value, which is the price we should sell the bikes at, is $230. Now it also said to find the maximum profit. So the profit for selling the bikes at $230 is equal to negative 200 times 230 squared plus 92,000 times 230 minus 8400000. All right, my wonderful math brain cannot do that one in my head. So let's see what we got. Negative 200 times 230 squared plus 92,000 times 230 minus 8400000. Ooh, that's a big number. It looks like the profit is going to be 2180000. We put our commas in, it looks like our profit is going to be $2,180,000. And we get that profit by selling the bikes for $230. Next up, a ball is launched in a way that the height h in feet of the ball above the ground after t seconds can be modeled by the function h of t equals negative 16t squared plus 48t plus 100. So we have the ground, and the ball is launched, and then it's going to come hit the ground. Hey, that looks like a parabola. How convenient. We want to determine the initial height of the ball. We want to determine how long it will take for the ball to reach its maximum height. We want to determine the maximum height of the ball and find how long it takes the ball to hit the ground. So starting with the initial height. What does initial mean? That's our starting height. So if we're starting, that means that t equals 0. So I'm going to plug in t equals 0 into this function. So the height at time 0 is equal to negative 16 times 0 squared plus 48 times 0 plus 100, which is 100. The ball started at a height of 100 feet above the ground. Next up, we want to determine how long it will take for the ball to reach its maximum height. Well, on the picture, where does the maximum height happen? Right about there, which is the vertex. So we need to find the vertex of this guy. To find the vertex, we use negative b over 2a. Usually we say x equals, but we have t in that place. So we will have t is equal to negative 48 over 2 times negative 16. And negative 48 divided by negative 32 is equal to 1.5. It asked how long it will take for the ball to reach its maximum height. So we're looking for a time. That's what I just found. I found t, which is time. It's going to take 1.5 seconds for the ball to reach its maximum height. In part C, it asks us to determine the maximum height of the ball. So we know that the ball's maximum height occurs after 1.5 seconds. I want to find its height at that time, and I can do that by plugging the time into the function. So the height at time 1.5 seconds is equal to negative 16 times 1.5 squared plus 48 times 1.5 plus 100. Let's see what that is. We have negative 16 times 1.5 squared plus 48 times 1.5 plus 100. I'm getting 136. This one's a height, which we're measuring in feet. So it looks like the maximum height is 136 feet. Finally, we want to find how long it takes for the ball to hit the ground. So we need to figure out what that means in terms of math, because we know it happens right here. We're trying to find how long it takes, so it sounds like we're trying to find a t-value. If we're trying to find a t-value, that means we probably know the h value, our height. Well, yeah, we do, because if we're hitting the ground, then our height is 0. So if I plug in a height of 0, I'm looking at 0 equals negative 16t squared plus 48t plus 100. That's a quadratic equation that we can solve by factoring or by the quadratic formula. I have a strong gut feeling that tells me this is not going to factor well. So I'm going to try the quadratic formula. It's been a while, so let's remember the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, instead of x, I have t. So I get t equals negative 48 plus or minus the square root of 48 squared minus 4 times negative 16 times 100 all over 2 times negative 16. Let's see if we can simplify that. That's negative 48 plus or minus the square root of, we want 48 squared minus 4 times negative 16 times 100. So we're looking at the square root of 8704 over negative 32. So I'm going to break this up into the two cases. Because of this plus or minus, we could either have the plus case or we could have the minus case. So if we have negative 48 plus the square root of 8704, and I divide that by negative 32, I'm looking at negative 1.415. If we do negative 48 minus the square root of 8704 and divide that by negative 32, I'm looking at 4.415. Now remember, we are trying to find how long it takes the ball to hit the ground. So we're looking for a time. Last time I checked, negative time isn't a thing. So that answer doesn't even make sense. This bottom one, 4.415 seconds, because it's a time, that one makes sense. So it's going to take 4.415 seconds for the ball to hit the ground. We have one more application problem we're going to look at. A purse store manager has found that when a certain purse is sold for $500, then 45,000 purses are sold during the month. The manager also noticed that if the purse is sold for $440, then 60,000 purses are sold. This place is good. Assuming that the number of purses sold are linearly related to the price of the purse, find the price that would maximize monthly revenue. So this is our goal, maximize monthly revenue. So let's think about what revenue means. Revenue just means the money you bring in. So when you sell them, the revenue is the money that you get for selling them. Well, to find our revenue, we're going to assume, based on this problem, that we're only selling one type of purse. Now, realistically, in a real store, there's more than one type of purse. But just for practicing, we're going to assume that there's only one purse. So to figure out the revenue that that purse brings in, we need to take the cost per purse and multiply it by the number of purses sold. So kind of like if you go to the store and a box of candy is $1 and you buy 6 of them, it costs $6. That's the cost per box times the number of boxes. Same idea here. We're just dealing with purses. So we want to find an equation for revenue. We need to find the cost per purse times the number of purses sold. Well, we see some sort of relationship here between the cost of the purse and the number of purses sold. And I kind of see this data being grouped as though 500, 45,000 and 440, 60,000. Because it says when this happens, that happens. So that means that the price we're selling them at is going to be our input variable, think X, and the number sold is our output variable, Y. So we just said X is the cost per purse. Remember, that's part of our equation for revenue. What I don't have right now is the number of purses sold. It says that the number of purses sold are linearly, so we're thinking y equals mx plus b, related to the price of the purse. So they say we can find a linear equation for those 2 points. We know how to do that because we have 2 points, so we can find the slope. M is equal to y2, which is 60,000, minus y1, which is 45,000, over x2, which is 440, minus x1, which is 500. That's going to be 15,000 divided by a negative 60. And 15,000 divided by negative 60 is negative 250. So we know the slope of our line. That's our m value. We still need to find b. So I'm going to pick a point. I think I'll use the first one. Our y value, 45,000, is equal to our slope, negative 250, times the x value, 500, plus b. So that means 45,000 is equal to negative 250 times 500 is negative 125,000 plus b. And if I add the 125,000 to the 45,000, I get that b is equal to 170,000. So remember, the job that we just did was we were finding an equation for the price of the purse. So if you give me, the number of purses sold. If you give me the price of the purse, I can tell you the number of purses sold. So let's say N for number of purses sold if you give me the cost. So instead of Y, I'm just using N of X to represent the number of purses sold, is equal to our M, which was negative 250, times X, plus our B value, which was 170,000. So we now have a formula for the number of purses sold. That's great, but we're still trying to maximize the monthly revenue. Revenue, I'll use R of X, is equal to the cost per purse, which we said is X, times the number of purses sold, which is N of X. So I need to multiply X times N of X. So our revenue is equal to X times negative 250X plus 170,000. And if I distribute my X through, I get negative 250X squared plus 170,000X. We want to maximize this. If we're trying to maximize, we are looking for the vertex. Vertex is x equals negative b over 2a, which will be 170,000 divided by 2 times negative 250. Oops, I forgot my negative in the numerator. So negative 170,000 over 500 is equal to negative 170,000 divided by 500. Oop, I missed my negative there this time. Is equal to a positive 340. X was the cost per purse. We wanted to find the price of the purse that would maximize monthly revenue. We found that X value. We are looking for $340 as our answer. Now I know there was a lot going on here, so I kind of want to recap what just happened. Our goal was to find the price of a purse that would maximize our revenue. We have to remember what revenue means. Revenue is the amount of money that we're bringing in. So if we know the cost per purse, then if we can multiply that by the number of purses that we sell, and that will tell us how much money we're bringing in. Well, they told us if the purse is $500, they'll sell 45,000 of them. And if the cost is $440, they'll sell 60,000 of them. Well, that price that we're selling the purses at turned out to be a really good X value. So X was our cost per purse, which we needed right there. Now we need to figure out how many purses are sold. They told us that the number of purses sold is linearly related. That's where this y equals mx plus b came into play, to the price that they're sold at. So we were able to create a linear equation from those 2 points. First we find a slope, then we find our b value. Once we have our slope and our b value, we created a function that represented how many purses were going to be sold. But remember, revenue is the cost per purse times the number of purses sold. We said that the cost per purse was x, the number of purses sold was n of x. So we need to take x times n of x. When I distributed through, I came up with a negative 250x squared plus 170,000x. This was our function for revenue, and we're trying to maximize that. If we're trying to maximize revenue, we're looking for the vertex. So we use x equals negative b over 2a, which gave us 340. We were trying to find the price of the purse that maximizes monthly revenue. The price of the purse, that was x. We solved for x. So that gave us a final answer of $340.